exists because they have all exploded within the last 50 years. And the human genetics has not changed so much in 50 years. It was not possible. So all of that is explained by environmental causes. Who can make the difference between GMOs? You know that in the States, the lifespan is shorter than in France. They eat GMOs, we don't. But I will not say it's due to GMOs. It's due to other environmental conditions, maybe. But anyway, who can decide? Because they don't label GMOs. We don't know if it's bad food, if it's growth hormone, antibiotics, some other chemicals in the food, or life condition, lifestyle, etc. We cannot decide. We cannot have epidemiological studies. So it's stupid to say, well, let's see the American people, they are eating GMOs and they go well. No, they don't go well. In comparison to Europe, they don't go well. So we cannot say that. And we cannot say their cancers are due to GMOs because they are not labeling GMOs. And the cancer takes 20 to 30 years to be settled. So, first of all, we cannot say GMOs are safe because American people are eating that. That's for sure. Secondly, we cannot say GMOs will feed the world and we need that. Why? Because during the last 15 years, 80% of edible GMOs were made in North and South America. And in North and South America, the poverty was enhanced, and the hunger was enhanced. There were more and more poor people needing feed and food. You know what we have fed with GMOs? We have fed pigs for rich countries. We are in a world where we prefer, with industrial agriculture, we prefer to feed pigs rather than poor children. So we have to face the reality. GMOs are not designed to feed the world. They are designed to feed pigs of rich countries, creating new metabolic diseases. As everyone knows, to eat a lot of animal fat gives more diseases, circulatory diseases and other metabolic diseases. So it's not a good thing to begin this kind of agriculture to give that to pigs. And it's not a good thing to increase soya and maize to feed the world. We need more diversity in agriculture to cultivate more than 30 seeds in each country or in each continent, and not to take strawberries from South America in order to import that here, to consume a lot of oil, a lot of pollution. So we need to change this phase of agriculture, and it is not with the present agriculture that we will be able to feed the world. So I summarize the major, okay, you can go ahead. The major edible GMO is transgenic soya. It's designed to absorb Roundup, which is the major herbicide in the world, and in the plant there are more Roundup residues, up to 400 ppm parts per million, which is a lot, because before only 1 ppm was authorized in residues imported in Europe, 1. And now the administration in the States authorized 400 ppm has Roundup residues in the food and feed, in the feed for animals, because there is more and more Roundup in the field. And Roundup is not even able to monitor all the weeds, because they have got more and more surprising weeds, and they need more and more herbicides. So do you know what is the solution for the GMO companies? They make new GM plants like the Smart Stacks, which is designed to make 6 insecticides and to absorb in the same time 2 herbicides without dying. This is a new GM generation. So they mixed the 2 characters more and more, 6 insecticides and 2 herbicides. Is it the way we want to go? To make like chemical plants, just bombs of herbicides and insecticides? Since we know that all those products are designed to kill, well, it's a job. It's called side because it's designed to kill. Of course, one way or another of the ecosystem, one step or another of the ecosystem, but like any drug, this may have side effects. You know, all the drugs have side effects. We know that in your boxes of drugs, of medicinal drugs, you have the side effects on the papers. We know that because of clinical trials and because of traceability. For the pesticides, we don't have clinical trials and we don't have traceability, so the side effects are difficult. But we see that more and more in agricultural workers, anomalies in genitalia of the babies, cancers, Parkinson's disease, all these diseases have been linked for some pesticides to human health. So it's not good if we design a plant to accumulate residues of Roundup, because HOLAB has demonstrated that from 0.5 ppm, so that's 800 times less than the residues authorized in the feed in the United States. So at levels 800 times less, we begin to kill and to disturb hormones of embryonic human cells. The hormones necessary to make the sex of babies. The hormones necessary to have normal reproduction when they are adults. The other big GM plant is a GM maize designed to contain insecticide, a lot of it, and to kill this butterfly, which eats the maize. It's a corn borer, and you also have other insecticides. So you have two major groups of insecticides in the GM plants, which are against Lepidopteran, which are butterflies, or Coleopterans, which are other kinds of small insects, in the roots, for instance. And in fact, each number of GM plant, you know, there is MON 810, MON 863, NK 603, etc., is either designed to absorb an herbicide like NK 603 or to contain a pesticide. And each number designs a different pesticide per itself. Even if they are inspired by the same natural pesticides, they have been all modified and patented and truncated and mutated in order to be artificial. So it's a scientific mistake to say that it's like a natural insecticide. It's a lie from the companies in order to get the acceptance of people. So for instance, you see the crystal which is in nature. The crystal, which is an insecticide, it doesn't dissolve normally in the plant. It doesn't penetrate the plant. It dissolves only in the gut of the insects in a basic in a basic environment. But it is soluble in water like it is in the BT maize. It's a different toxin. It's 44% different than the natural toxin. And this is just for one kind of BT maize. All the other BT maize have differences. So it's not the natural toxin which is inside the GM maize. Okay, so pesticides and GMOs, similar problems. 99% are designed to contain pesticides. This is not going to change rapidly. And the next 10 pending GMOs have these characters. The actual ones were commercialized 8 to 15 years ago, and nothing new on a large scale. for the next 5–10 years. So the difference with pesticides is that GMOs are living organisms and even less evaluated than pesticides, less assessed, because pesticides have been tested on rats for 2 years, for a lot of them. Not very well, but for 2 years, so in some instances. There is no commercial GMO around the world that has been given more than 3 months to a mammal with blood analysis before commercialization. And this is a shame, you know, because they want to say to several generations of people all over the world, this is good to eat, no problem, but they are not able to give blood analysis of mammals that have eaten that more than 3 months before commercialization. You know, this is taking the human health as nothing on a chronic way. Of course, this will not give, it is not a poison that will give immediate disease. No, because we know that the effect is not in a short term, because it has been given 3 months to rats. That's almost 10 years of a human life. A rat lives around 2 years. But what about chronic disease? Like a lot of pesticides give chronic disease. If these herbicides are already able to kill or to disturb embryonic cells, what will they do with rats on the long term? And what will they do first on a short term after 3 months? We ask this question. We ask this question to Monsanto company. Please give us, because I was in the committee in France, please give us the blood analysis of the rats that have eaten your GMOs for 3 months. In 2000, this was not existing. They were not giving that to animals taking blood before commercialization, because they said it's a plant like another one. There is substantial equivalence. That means the composition is almost the same. The maize resembles to a maize. So it's not necessary to give that on a long term or on a mid-term to animals, because this costs a lot of money. And if you want to do that, we will put you at the WTO level on conflict. That's what they did. If you want to label that, we put you at the WTO conflict. That's what they did. Because they say, it's a plant, it's a natural plant, like another one. We changed 1 gene, but when you cross 2 maize, you change 100,000 genes, because there are 100,000 genes in the maize. So you don't test that during 3 months on rats. So don't test our plant during 3 months on rats. You don't have to. It's a plant sufficiently different to be patented, but not sufficiently different to be labeled. This is, you know, this is very intelligent system. Sufficiently different to be patented, but not sufficiently different to be labeled. And all the benefit is on this misunderstanding. So we